This video will show the test vehicle that we have used to demonstrate an improvement in gas mileage ranging from 30 to 35% using hydrogen that is extracted from water. Water is 2/3 hydrogen, so from the water we can extract quite a bit of hydrogen using aluminum and our proprietary catalyst, which is catalytic carbon. The result is hydrogen gas, which is routed into the intake manifold of the automobile engine, and in an otherwise unmodified engine, it performs better with better combustion efficiency to yield a mileage improvement of 30 to 35%. I'll show you the test vehicle here. I'll get down in the field of view and show you that we've modified a 2004 Buick Park Avenue. It's got about 160,000 miles on it, and it's running better than it did 10,000 miles ago. We think the hydrogen has actually cleaned it out a little bit. I'll give you a better detail on the next view that will be a close-up of the components that are mounted on the shelf on the outside of the Buick. We've chosen not to compress this into a small area and small volume and load it under the hood because we'd spend a lot of time with the head under the hood. So we've mounted everything on this test workbench just to make it easy. The purpose for this shot is to show you the cell that works here. It goes into a bubbler to show hydrogen action, then into a cleanup chamber. Then the gas goes over to a solenoid. We have a current system here, a meter to measure the current draw, and a switch to control the whole entire system. I'll explain more of the components in a moment. I'd like to explain what's inside the 4-inch PVC tube. The PVC tube is fairly tall, and it's going to contain two sections of the cell. In this section, which I will show you an expanded view of, it contains the electrolysis part of the cell. And that is used for heat up, and it provides instant hydrogen to the engine, even during the heat up phase. Down here, you can have the aluminum and the catalytic carbon and the water that is generating hydrogen, but that will begin to generate hydrogen only after it's heated up. So it's a two-phase cell. We use electrolysis where we apply power for heating and instant hydrogen. Then we switch over to just the hydrogen produced by CCHOD, and that happens when we use a digital temperature controller to turn off the top part of the cell. Now I'll show you the top part of the cell, and it might be sitting in here something like this, and it would be not very far off the floor of the 4-inch tube, depending on how much material you had in there, how much aluminum and how much catalytic carbon along with the water. So now let me just show you the inside of this cell. It's composed basically of three sections. I'll expand this so that you can see them. The outside section is the anode, and that's where the oxygen is generated during electrolysis. And it just goes right out the vent and does not go into the collection area. The collection area has no slits in it whatsoever. You can see that with this part of the very top part of the plastic area. However, the bottom part of the plastic area does have slits in it so that you can support good current flow between the anode and the cathode. So the cathode then is actually inside the plastic, and that's where the hydrogen is produced during the electrolysis phase. So when it's all together, it looks like this. Hydrogen is produced inside the cavity near the electrode, or near the cathode electrode, and it comes out here. The oxygen is produced outside, and it is vented but does not get into the port. Then, when the system is heated up properly, we turn off the electrolysis section. We no longer want to dissipate power if we've heated it up enough, and we use then the material that's below this to bubble pure hydrogen up into the collection area. Most of it will go into the collection area because the diameter of the bottom part of this part of the cell is almost identical to the internal diameter of the section of PVC that it's housed in. So I've tried to show you the two-section approach using electrolysis for heat up, and then if you need to warm it up later, you can use the digital temperature controller to control the power on and power off. But most of the time after it's heated up, you're using only the CCD generation of hydrogen using aluminum, catalytic carbon, and water. For additional information, you can review information on our website, the hydrogen website, or you can contact the company directly.